Okay, I have a problem that I need to solve. I have a fan, a normal fan that I use to cool off the room, and it constantly leak live voltage to the chassis of the fan. The reason is that this is the controller, not the controller, the switch for the fan, and it constantly make contacts with the fan frame over here. And because this is metal, and the fan frame is also metal, I my family get a pretty nasty shock because of it. And the reason those two parts touch is due to this part over here, the black part. Yeah, the black part over here is broken. And last time I used some nano tape, sticky tape, or hot glue sort of stuff to try to glue the two black part together. And because I don't think I can find this part readily available in the market or online, so I'm gonna just 3D model it right here. And yeah, that is what this video is about. So let's get started. This is in real time. I haven't even made any measurement for it. So this is actually like a stream session. Okay, everything is zeroing. The thing looks something like this. Let me check the orientation of the part. Okay, look like that. So I'm gonna model it in the orientation that I'm going to print. I will try to be as faithful to the part as possible. So sketch. I'm gonna sketch in the which orientation should I sketch in first? Let's go top down. Yeah, let's go top down because this is the orientation that is the most important for me. It's white plane. All right. So some basic measurement first. This is practically an L-shaped part. This is 22.10 millimeter. I'm gonna use the GM. I believe this is this button. No, GL, not that one. Okay, GM. All right, let's start in this corner here to here. I don't believe this is the part. No. No. My bad, my bad. Switch it back to normal geometry. Here. I'm going to add the hole later. Yeah, I'm going to add the hole later. So no worries about that. Go to the side, going up here and here. The thickness. Let me check the thickness of all the part over here. It seems to be uniform at 3 millimeter. Yeah, give or take. 3 millimeter is the upper bound for this one. Yeah, so let's go with 3 millimeter sharp. So they are equal to each other. And 3 millimeter. Right. Now for the dimension of From there to there is 22 millimeter. Crap. Put it in. $22 millimeter. Yep. And this side is, let me get a good measurement, 31 millimeter. Is it due to the excess plastic? Yeah, let's go for 30 millimeter. No, sorry, 35 millimeter. Let's go for that. 1 second. Okay, that long edge is 35. Okay. Okay, it's good to me. I don't think I need to fill it. Should I fill it that angle? No, I can fill it. I should fill it that part later. There are some asymmetry in the part, so I need to be careful about that. Okay, don't seem to be a problem. Okay, that is the top-down profile of this thing. Okay, let's make it. That is the top-down profile. Close, and we will extrude it by the photo. By how much? By 59.50. Let's round that up to 60 millimeter. Yeah, I believe we can round that up to 60. Okay, got the dimension. Let's name it top profile. Nice. Okay, alright. Now we have a short and a long part. Now we will perform the cuts. Yeah, the cuts for this. Okay, there's a need to be square arm, so you can actually get away with that. But the most important dimension, let's see, is the holes. Yeah, the holes is the most important part that I need to get correct. I try to use a soldering iron to weld them together, but it didn't work out. Okay. Okay, let's make the cuts in this direction. So if I make another sketch, it will be in this plane. Perfect. I'm gonna reference it like so. Double check. Okay, we're in the correct plane. So this is the L-shaped part we have. I think we should make another reference to X of this line. Yeah, got it. Boom. Okay, I want to make a cut over here and over here because it's really hard to tell from just the part alone. Yeah, this I really should have take a picture to show you, because this thing is not. So this is the L profile. You see the L right here. I'm gonna model the. I think I'm gonna make a bolt hole instead of a thread in, because 3D printing is not that great for thread, for self tapping thread, in my experience. So because the part over here is breaking, we're going to model the part over here first. Let's go for that. Okay. Now we will perform a cut. And to do that, we need to get the following measurement. First thing, from the bottoms up, cut by 10 millimeter. So I'm gonna go GM. Sorry, GM. Yeah. So how should I make this cut? You know what? I'm gonna make a cut around this area. No. Not that constraint. Here, here. I'm just gonna give it a general shape like that. And slowly define it one by one. So, because the part is breaking, because the part is broken, I need to make multiple. So that is 10 millimeter. Okay. And about the depth, it's hard to measure the depth when it's breaking like that. Another 10 millimeter, I believe. Yeah. So the distance from here to here is 10 millimeter as well. Okay. I think we can make it intersect over here. Because we're making it a cut, the cuts have to be an enclosed shape like that. So we cannot just make two separate square over here for the cut. Okay, got that cut profile done. Now for this one on the top, they have different dimension, so I would need to make another one. $15, $16, $17. Let's go that for $18. Yeah, 18 looks good. $18 millimeter. Those two should be equal. And the distance from here to here, I'm gonna give it, let's give it 5 millimeter for us to easily see the dimension. Okay, that looks good. Yeah, that looks pretty good. But There is also the hole inside that we have to take care later. Give me a second. I think I can chamfer it later. Yeah, I can chamfer it later. Reverse. Through all. Yeah, through all is good. Good for that. Should I complete all the operation on one side first? Yeah, I should do that before moving on. Now I need to make the holes because these holes need to fit a, how many millimeters is it? 1, 2, 2, 3. Okay, 4. So it's like an M4 bolt. So yeah, so let's give it for about 4.5, 4.2. Just based on the real measurement, 4 millimeters enough. Right? Yeah, let's go for 4 millimeter. Should I? Give me a second. I prefer my calculation have a bit more margin. This is for to compensate for the clearance. I'm not sure about the clearance of my printer. Maybe 4.5 is a bit much. GNGY make GL, my bad. GNGL from here to here. Make sure those connect, and the distance between them. Second. Distance between them is 23 millimeter. Okay, 23 minus 4. Guess I measure end to end. Okay, got that one. Got the dimension that we want. Maybe do they are symmetric? Yeah, they seem symmetric enough. So I'm gonna make the center line and make the two circles symmetric to that. Close. Shift extrude. And yep, we got a holes for it. And for both holes. Okay. Let's name it short L cut. Yes, because this is short side of the L. This thing is currently failing DFM. I'm gonna have to perform a very aggressive cut. This thing isn't, yeah, this thing is definitely not a problem. So I will need to make a chamfer. Do I have the clearance for it? Yes, I believe I do. I believe I do have the clearance for the chamfer over here. Okay. Upper side's fine, no problem with that. Maybe a bit of a fillet to reduce the stress. I don't think that will work with 3D printing, but whatever. Yeah, the problem desperately need. Maybe I do. Maybe I can add it. No, I don't think I have the clearance for that part. So chamfer for the lower one still work fairly good. Let's sketch it quickly. I want you to see the result in this video right now. Okay, this line, how is it working out? Okay, we are mounting from over here, so from the outside, yeah, from the outside of it. Okay, measurement gonna be a pain in the ass now. Yep, I think I can handle it. We will take reference geometry so that we don't cut into the thickness over here. Turn it off. Yeah, maybe another one. And another one. Okay, we got the overall profile that we need. Now let's make some cut. So this part is just a single cut. Should I add the hole before the cut? Because this part is originally designed to be screwed in. But I think I can make the bolts for it. All right, I'm gonna have get something to eat. I'm gonna come back later. Think I will wrap some bolts. Most of the bolts I have is, to be honest, too long, far too long for this. Thing. Secure. Even you like that I don't have that many M4 bolts to begin with. I really should I really should have built a bolt sorter because it is starting to become a mess. Yeah, that will be a future main problem. Not enough bolts for this thing. Okay. So, okay. The washer, is it still through? So I believe I can use the washer. Like that. Okay, okay. Let's look good. Let's see if that's good. I'm gonna use silver. And one washer is enough. Okay, got the washer. Let's uh, let's measure for the cut, shall we? The design is nice. It took on a pretty, let's say, circular shape like this. I don't know. It is a terrible way to make it. Let's start from the edge. Okay, goes there, and then create an arc like that, a 90 horizontal cut. Another one like that. That over there. Okay. What is this point even do? Oh, okay. I need to delete that. Okay, okay. Do it again. I don't really need to make the ends over here round, so I think I will cut corner over there. This thing and this thing should be at a 90 degree. It's a bit less than a 90 degree, but how should I model this thing? Does it look like that? Okay, okay. Horizontal constraint. It should be vertical together. Nice. This part is centered. So I'm gonna make a point here and make that point symmetric. Nice. Got that one. Let's measure how deep this section is. So how should I measure this? Oh, this is actually pretty nice. I can subtract probably a 2 millimeter down, 1 millimeter down. So I'm currently at 11, so this cut is probably 10 millimeter. And about the horizontal one. 15, 14. Looks 14 to me. Next. Yeah, 14. Okay. Let's make another symmetric point. Here, 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 symmetric. Okay, those are symmetric. Now I'm gonna make a arc, a very big arc, right? From here all the way to here, and make it contact. All right, this one should be N. Okay, let me measure the thickness of this area that I will mount the bolt. Mounted the bolt to. About 10. So do we have 10 millimeter of material over here? Okay, we do not. Okay, how do we do this? From here to here, I want to have like 10 millimeter of material. Okay, span it a little bit like that. It's 10 millimeter too much. Let me check. Okay, I can work with that, no problem. This is an M3 bolt, right? So shouldn't take up that much space to begin. Yeah, I'm just gonna make a hole for it. No fancy stuff. Here. Let's pray that it works. Okay, what is the problem? Oh, okay, I see the problem now. Ah, now it is fully constrained, and I just need to trim the part over here. Doesn't feel good, you know. Something about this thing doesn't sit well with me, because it's gonna be a hell. It's gonna be hell to print. So what I need to do is to maintain the profile over here. So this is a profile, and I need to improve upon it. Okay, okay. I believe I can do this. Okay, there's a profile, no problem. And I need to make it printable. What the heck I'm going to do with that? Let's say GM, and I make it 2 line, maybe. Yeah, because from here to I don't care about the angle from here to here must be, I believe 60 is the decent compromise I can make for it. Make it tangent. Okay, so that is the maximum angle my printer can print vertically without needing support. And now I make the arc across it. here. Okay, now we have the arc. For some reason, automatic constraint doesn't work, so okay. So it curves up like that for ease of print, and that thing should just have a 90-degree angle. Or better yet, I can make something nice. Like that. So it doesn't have the awkward layer lines over these angles. What am I doing with that? Um, looks a bit stupid, I know, but oof. Oh, at least everything's going according to plan. Oh yeah, it's not going according to plan because where's the angle? Where's my 70-degree angle? Yeah, there. So just for reference, GC, this is what a 4 mm hole will look like. Wait, this is M3, M4. I remember this is M3. Double check, double check. M1, 2, 3. Yeah, this is M4, M4 bolt. Okay, this is how it looks. And you have a very thin margin over here. Is this thing acceptable? That is the question. Okay, let's double check one last time. Why do I need a part over here? It is a very bad overhang. Okay, it is to fit the square part of the fan. This is bad overhang. So let's delete the line. Try to make something better. GN. I got the profile. Now we just need to. Oh my goodness. Let's connect. Right. Got that one. Now I need to. I cannot violate the inside perimeter, right? But I can go over it. So how am I going to do that? So can I extend the line? For example, to here. And the angle must also maintain at 70 degrees. It's gonna look something like that. And I believe I can have some leeway over here, maybe. Looks very sketchy, I'm not gonna lie. I will try this part because it's quite thin. It will vibrate during the printing and will collapse. That is my biggest concern. But ooh, tricky, huh? Okay, instead of doing that, let's take how about I take a two-step. No. GL. Because I don't want to cut too much inside, you know. This part I cannot remove. Yeah. Wait, what am I doing? I can just do back, 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 back. Okay. I can just make this thing 70 degrees, so I can add another line from here to here. That is also 70 degrees. 70 degrees, really pushing it, but maybe 60. This part is a bit critical. Wait, what? All right. Wait, why the heck not? What's the problem here? Because if I can do that, I can make this thing compliant again. So 70 degrees is okay, but not 60. 60 degrees is just a bit higher up. I don't see any problem with that. What the heck is this? I don't see any error pop up. I think I have disabled that before. Let's do it again. So from here, 60, can it give me a 60 degree? Okay, good. Can it connect? Oh, I'm a fucking idiot. I'm sorry. Sorry, FreeCAD, for doubting you. Okay, let's try to trim it. Let's hope there won't be any consequences. We and try to trim this section. Not looking well. Okay, this thing is now print compliant. Can I perform a cut for it? Of course I cannot, because it is not an enclosed shape. Can go from here to here, and now I can cut it. Still not. What the heck? What's wrong? Wire not close. Good. Okay, got that. Can I? Yeah, this is the problem with the adding the hole. So if I had added hole over here, I cannot perform the cut. Okay, seems to be compliant. Yeah, now for the bolt hole. let's measure the distance between. Yeah, I'm gonna need that. So this is long L cut and sketch on that same plane. Same plane of resistance GX. Gonna need that, and I'm going to need that. Do I even need that one? I don't think I do. Right? Okay, let's start some measurement. This should be a 4mm hole, and there to there is 23mm. Oh no, looks a bit short than I expect. So, no, not 23. 28. 28 minus 4. Maybe not minus 4 because this hole is. This is basically an M. Let me double check. An M2. Maybe. Yeah, it looks like an M2. Good. Yeah, this thing is an M2. So more like. Forgot a number again. I'm not a bit retarded. 6, 7, 8, 28 minus 2. Boom. 6. And from the top, it is 4. No, wait, not minus 2, minus 1. So it should be 27. I'm not measuring from hole to hole, right? So from the side, like that, it is 1, 2, 3, 4. It looks like 5mm to me. So plus the center is 6mm. The hole we are modeling is an M4, but the hole I am measuring is an M2. Same thing. I probably should add a teardrop shape for that one. Vertical. 7. What? Yeah. Okay. Doesn't need to care about that. 6. $45 number. 30. So this is 45, right? No, this is 90. Okay. And go from this one to the axis is 60 degrees. I want the tiny one like that. Same for this thing. Let's go. GT to trim. And I got that. Can I perform a cut in a reverse direction and through all? Looks a bit crooked. Goodness. Does it really look like that? Okay. I believe there are no better ways to test this thing than to actually test it. Are there any more dimension that I haven't measured? Well, if not, okay, let's start with the chamfering. So let's name it M for both. Surprisingly, both of them are M4. Oh, I forgot to do the teardrop. I believe there is an extension for that. Okay, and this part needs a bit of an adjustment, but I'm gonna let it slide because right now I'm basically performing very crude sketch. Boom. Okay. Now for the fillet. Good. Let's give them a 3mm fillet. No. 2. We're stopping it. You know, this part over here. Let's see. I should fillet the corners. Will it affect the mounting point? I don't think I should fillet that part. But the edge above should benefit from that. This is a very sharp corner. I think it will like that, but yeah, who knows? All right, I'm gonna now print this thing. Okay, so we have this little part that we just measure and print out. No, this is the original part. I'm sorry, this is the original part that broke, and after a bit of measurement we got this thing. I may have given it a little bit too much clearance. Some of those clearance aren't even necessary. Yeah, I don't think the part here is needed. Yeah, I don't think the section here is needed. By the way I mount this thing, but this thing even have a crack over here. Oh, but still working. And yeah, that is how you fix a broken plastic part with a caliper, FreeCAD, and a 3D printer. And yeah, this is the kind of stuff that 3D printing allow me to do. Instead of having to settle for dangerous fan chassis that got electrified with live voltage, I just create this thing, solid PETG, so I think it's gonna last quite a while. This is actually the plane of printing, so the flex on the L part is going to be very strong for the application. And for both work flawlessly. The measurement we made to mount this thing right in there, yeah, work like a charm. I cannot fit the button onto the shaft because it is a little bit shorter. Focus, yeah, a little bit shorter. So I think I'm gonna need to add a couple millimeter. Close up this edge and improve it a little bit more for the print, and I think we will be good. This is the new fit compared to the old one, and you can see this could have gone a little bit more in there, but otherwise everything looks fine. Hold on a second. Alright, fit like a glove. Not that not really a well-made pair of gloves, but hold on another second. Right, not the perfect fit, but it will do for now. Time to put the fan together for the test run. Alright, testing it again. Fan is running. Don't mind the vibration, it does that all the time. Gonna test the chassis. It's plugged in. Testing, no power. God damn it. I think you might not be able to see it, but there are still some leakage. Yeah, I think it is. There's still some part touching it. Yeah, it's still not safe to use. Okay, back to the drawing board. After some further testing, I'm hooking one end of the multimeter to the neutral and one end to the chassis, like so, and I'm measuring 11 volt AC. Of course, 11 volt AC will still make this thing light up like that. Focus, yeah, you can see it light up. And because yeah, so I'm not dying right now, I'm touching the ground, so 11 volt is not enough to kill me, but I don't understand how there can be that kind of leakage. I double check and triple check, there are no contacts. I think there are some sort of parasitic load, not parasitic load, but parasitic coupling that cause some AC voltage to be, what is the correct word, induced in the chassis. So this is the frame, nicely made. This is actually the exposed contacts. You can see, yeah, those are the contacts. The capacitor, everything is nicely put away from each other.
So yeah, that's about it.